Try it. Right now, run your fingers across your ribs. Drag a fingernail across the sole of your foot. You feel the touch. You feel the pressure. But the uncontrollable laughter never comes. Why? Here's the weird part. Your fingers haven't even touched your skin yet, and your brain has already decided that what you're about to feel isn't important. Your brain cancels the tickle before it even happens. That sounds impossible, but it's real. And understanding why takes us into one of the most fascinating and quietly unsettling systems inside the human brain. A system that's running every second you're alive. A system that's constantly predicting the future, at least your future. Every second you're awake, your brain is making millions of tiny predictions. Where your hand will be, what your eyes are about to see, what your skin is about to feel. Most of the time, you never notice. But tickling exposes this hidden system better than almost anything else. So let's look at it properly. Think about the last time someone unexpectedly poked your side. You probably jumped. You laughed. Maybe you even tried to push them away. Now imagine doing the exact same thing to yourself. Nothing. Same fingers, same ribs, same skin. Completely different experience. So what changed? Not your body, your prediction. Long before humans lived in cities, our ancestors survived by reacting instantly to unexpected touch. A brush against your ankle in the dark could be harmless grass, or it could be a snake. Your nervous system evolved to treat unpredictable touch as urgent, as a potential emergency, as something that demanded your full attention immediately. That's why the most ticklish parts of your body are also some of the most physically vulnerable. Your ribs, your neck, the soles of your feet, your armpits. These aren't random. A bite, a sting, or a blade landing there could be catastrophic. So your nervous system placed its most sensitive alarm system exactly there. Unexpected contact in those places triggered a response. Your body snapped to attention. You protected yourself. That response was the tickle. But your own fingers are never unexpected. Here's where it gets incredible. The instant you decide to move your hand, a part of your brain called the cerebellum creates what neuroscientists call a forward model. Think of it like your brain texting itself before anything has happened. Don't worry, those fingers are ours. Before your hand even reaches your ribs, a signal races ahead to your sensory cortex. Expected. Ignore this. By the time your fingers arrive, the sensation has already been turned down. Not muffled, not reduced a little. Cancelled. Your brain saw it coming and decided it wasn't worth your attention. Wait. How do scientists actually know this? Because they built a robot. Researchers led by neuroscientist Chris Frith at University College London ran a deceptively simple experiment. They asked people to control a robotic arm that would then tickle them when the robot moved at exactly the same time as the person's hand movement, in perfect sync. Nothing. Still not ticklish. But then the researchers introduced a tiny delay, not a long pause, just a fraction of a second, a barely perceptible gap between the person's movement and the robot's response. And suddenly, people started laughing. That tiny delay was enough to fool the brain. The prediction no longer matched reality. The signal that said, "Expected, ignore this," fired too early. The sensation arrived slightly outside the predicted window, and without a perfect prediction, the tickle came back. Your brain can only cancel sensations it predicts perfectly. Think about what that means. Frith's team went further. They tested different delay lengths. The longer the delay, the more ticklish the sensation became. At around half a second of lag, people were almost as ticklish as they would be if a stranger's hand had appeared out of nowhere. The brain didn't need much uncertainty. Just a sliver. Just enough to break the lock. Now here's where it gets much bigger than tickling. That system, the one that sees your own movements coming and quiets the resulting sensations, it's doing far more than protecting you from false alarms. It's building your sense of self. Every second, your brain is drawing an invisible border. On one side, you. On the other side, everything else in the world. Every movement you make is compared against what your brain predicted would happen. If the sensation matches the prediction, safe, ignore it. If something arrives that your brain did not predict, pay attention. That came from outside. That invisible, constant comparison is one of the core mechanisms of self-awareness. Scientists call one part of this system the efference copy. Every time your brain sends a command to move, it sends a copy of that command to your sensory system at the same moment. It's an advance warning, a notification sent before the sensation even arrives. We're about to do this. You've been warned. Without that copy, your own actions would feel foreign to you. Every blink would feel like the world going dark without explanation. Every footstep would feel like the ground rising up to meet you. Even the sound of your own voice could feel like someone else was speaking. You would feel like a passenger inside your own body, stranger in your own skin. In some neurological conditions, that prediction system doesn't work properly, and the results are deeply revealing. Some people with schizophrenia can actually tickle themselves more easily than most people can. Not everyone, not all the time, but researchers including Frith have documented this pattern in studies. The reason matters. In schizophrenia, the brain can struggle to correctly tag self-generated actions as coming from the self. The efference copy misfires. The "we did this" signal doesn't always arrive correctly, so when the hand moves, the brain doesn't fully cancel the result. It isn't sure if that movement was its own, and the tickle gets through. Some of the most distressing symptoms of schizophrenia feel inserted from outside. Movements that feel controlled by an external force are connected to exactly this breakdown. The machinery that creates the feeling of authorship over your own actions, the feeling of being the one doing the thing, is the same machinery that cancels the tickle. That's not a footnote. That's the whole point. Tickling is a window into something that neuroscience is still working to fully understand. The mechanism that makes you feel like you. But let's come back to the laughter, because there's still something strange left to explain. Why do we laugh at all? Laughing doesn't feel like a response to danger. It feels like the opposite. So what is it doing there? Research by neuroscientist Robert Provine, who spent decades studying laughter at the University of Maryland, found that tickle laughter is largely automatic. People laugh even when they don't enjoy being tickled, even when they're not having fun at all. The laughter isn't expressing joy. It's doing something else entirely. Some researchers believe tickle laughter originally evolved as a social signal during play, a signal sent to whoever was touching you. It says, you have access to a place I can't easily defend, and I'm not fighting back. It's surrender. Safe surrender. A flag that says, this is play, not attack. Jaak Panksepp at Washington State University, who spent his career mapping the emotional circuits of the mammalian brain, found something extraordinary. Rats, when playfully chased and tickled, produce ultrasonic chirps at a frequency too high for human ears to detect. These chirps are now widely described as the rat equivalent of laughter, and the rats that chirp more seek out play more. They approach the researcher's hand. They want more of it. The laughter doesn't follow the fun. The laughter is what signals that the interaction is fun. It's what keeps the game going, which means tickle laughter might be one of the oldest social signals on Earth, older than language, older than human connection as we understand it. Play might be far more ancient than we ever imagined. So next time someone catches you off guard and you laugh before you can stop yourself, here's what actually happened. Your brain failed to predict another person's movement. For one brief moment, reality outran your internal model of the world. Someone moved in a way you didn't see coming, and your ancient alarm fired, your body surrendered, and the laugh came out. You couldn't surprise yourself because your brain is always one step ahead of your own hands. It knows what you're going to do before you do it. It has been running that calculation since before you had a concept of yourself. But someone else doesn't share your motor commands, doesn't feed into your forward model, doesn't send the advance warning. Someone else can always get through, and maybe that's the strangest part of all. One of the simplest ways to prove that another person is truly separate from you, truly other, truly real in a way your own mind cannot replicate, is that they can make you laugh in a way you never can. Try to tickle yourself again. Nothing. You already know what you're going to do. You always do. Make sure to like the video and subscribe to the channel for more content like this. And as always, have a blessed day.